Marisa, for a nice introduction. I'm pod honored and a bit ashamed. Thanks.
Hello, everyone. I'm happy and excited to be here today and meeting with you all. I will be talking about pretty much my research on non-menus and much more my questions about how we should capture them and we analyze them to have better sign language linguistics discussions and like theoretical analysis. I want to briefly introduce you the structure of sign languages, really short. Sign languages are simultaneous. What I mean by this, they have hands, face, body, we call these non-menus, and space to encode the information. Thanks to this simultaneity, they have high information content. Studies also show that age of acquisition and how long kids exposed to sign affect the production and perception skills of signers later in life.
Serpil, very sorry, just 1 second. We can see presenter mode rather than slideshow view.
Oh, sorry.
No, it's all good.
Let's try again. What about now?
Yep, that's a slideshow mode. Thank you very much.
Okay, and I will continue where I stopped. Okay. I will show you a sentence from ASL and we will discuss it later. And as you see in this video, we have the hands, manual signs, which encodes the content like boy, bike, crash. And also signer uses the space to introduce these like boy and bike and how the crashing is happening. She also uses her facial expressions like brow raise to convey focus, emphasis, and like other facial expressions to convey how the event happened. So all these components working together. I will be mostly focusing on the non-menus, and they are shown to occur across different linguistic domains like phonology, morphology, syntax, semantics, and pragmatics, like in all the structure in sign languages. Yet we understand them least compared to the other parts. One reason is more than one non-menu can co-occur and they can move more than one direction, and we don't have robust strategies and technology to capture them yet. I will focus more and specifically look at one non-manual marker, head nod. In the literature, previous studies show that it either functions across domains like prosody versus semantics. For example, it is argued that single head nod in ASL functions as a boundary marker in a sentence. And repetitive head nods shows us the certainty of signers in ASL. While the boundary marker is prosodic, certainty marker is more semantics and pragmatics. When we look at the literature, we also see that same non-manual head nod can occur differently, like smaller repetitive versus single and clear. And with these smaller and repetitive nods, researchers observe that we are getting the lower signer certainty. But when it gets like clear, single, and more repetitive, we are getting higher certainty. Then the question is, do we have the same head nod across all these studies, or do we have different head nod mapped to different motions? And today I will be comparing two analysis metrics. One is behavioral and the other one is computer vision tools. To present these comparisons, I will be using data from the different study, and we will be focusing on one condition in this study. I am happy to provide more details during the Q&A about this study. And why we are focusing on this condition? Because we have two clauses, like two sentences. One is where the signer fails to do the event, like fanning the fume with teaspoon. And we see the head nod at the end of this clause, but it doesn't convey us any success or failure. It only shows us signer is still continuing their sentence or discourse. Second sentence, following the first one, is a successful event with the right instrument, like fanning the fume with fan. And in this case, we have a head nod conveying us to success. So we have same non-manual occurring in two different functions. One is like boundary marker, as discussed in literature before. The other one is like success, which conveying you that event was successful. So to show you this clear difference from the Turkish signers, now I have two videos. First one is cut from the end of the first clause, and the second one is cut from the end of the second clause and end of the sentence. I hope you were able to catch the difference, but there are nuance differences between these two movements. And I'm curious if these two differ in their phonetic features. And remember, we have both American signers and Turkish signers. And do they use it distinctly or similarly? First, I will show you the human annotations. And we look at all the data as annotated and object and verb and annotated if the non-manuals occurred during this time. Specifically for head nod, we annotated if it appeared, if it was multiple or single, and if it is clearly visible or not. In this graph, we are seeing the proportions of head nods across languages and the conditions. And what we see is highest graph tell us that we have the higher proportion of head nod. So good news, yes, we observed it. But still, this doesn't tell me if we have the same kind of head nod or different head nod in both positions or not. So based on results, when we look at our research question again, we partially answer it. Now we know they occur in both positions, in both languages. Yet we still don't know if they are same head nods or is there any difference among them. So another addition is these annotations are taking immense time, like requiring at least two people going over and over hours of recordings. To complement these results, I also use the computer vision tools like MediaPipe. And it enables us to find points on the video. In our case, for the head nod, like the facial points, and track these points across the frames. So we can measure the trajectory, like specific features as amplitude, velocity, peak, and trough. Remember that we use the same label, head nod, for these two movements. But when we look at it with the media pipe, we see differences. In this figure, the left panel two figures are from ASL, and right one, two are from TIT. For ASL, they look pretty much similar. First one is the C1 head nod, second one is the C2 head nod. And when we look at these trajectories, they look like similar. And for TIT, here we see the clear difference. First one is C1 head nod, end of the sentence. And second one is C2 head nod, end of the second sentence, and conveying the success. For the first one, signer's head position is more neutral, and then it goes down and then up. For the second one, it is neutral, it goes up and then down. Then I took these trajectories and compared them with each other with the dynamic time warping. And this helps us to see if these head nods are similar or different. Okay, so before discussing the results, to show you the figures, so we have both ASL, TIT, and the two head nods in this figure. The colors show us like combination of language and the head nod. So blue is for ASL, first head nod, and red is for ASL, second head nod, the success head nod. Green is TIT, first head nod, and orange is TIT, second head nod. The circles shows you the mean of each participant, and the area is like where all these participants group together for that specific head nod. So what we are seeing is orange and red grouped together. And that tells us that these two head nods are not different from each other. And these are the second head nods, success head nods. And for the green and blue, they group differently from each other. And also they group differently than second head nod. These are the first head nods. And these are different than success head nod. And these are also different in each sign languages. So these results shows us these trajectories are mapped to different functions. So for both ASL and TIT, they map the first head nod for the boundary, but how they are realized is also different. For the second head nod, this is mapped to more semantic notion, which is the success or completion of the event. To conclude, we have complementing results from behavioral analysis and computational analysis. Behavioral analysis showed us where we have the head nods. Computational analysis showed us what differences we see in these head nods. And more importantly, they showed us we have two big categories for head nods. Yes, the first head nod is different than second head nod across the languages. And more importantly, first head nods also distinct in ASL and TIT. And stepping back, the bigger picture question. So I think while we are discussing the non-menus in theoretical linguistics, we should first capture their differences in these form meaning mappings and where they are falling in that regard. What I mean is we have the same non-menu, and if we just keep that label and try to put it in both prosody or semantics or different areas, we will get a clashing discussions. But if we take this head nut, in our case, with its trajectories and features, then we will see a clear distinction in these forms alongside with the meanings. So sign languages take these non-menus and their differences in realization, and either they assign it to different subcategories or different domains. So what I'm trying to say also, their function doesn't have to be prosodic semantic per se, but they do have their own prosodic features, and these can be mapped onto specific functions. And we can use the available computer vision tools to capture these nuanced distinctions between them. And of course, we have both sides of the story, but we also have the challenges. So as I already bring out during presentation, human annotations require significant time. And humans can miss these nuance differences. Honestly, if you show me for the first and second hand in ASL, I would say these look too similar compared to the tip. So it is not always that easy for human eye to catch these differences. Computer vision tools also fail when hands are in front of the face. Let's say I have a sign father coming to my forehead in ASL, and this will occlude the vision. And not all the tools sensitive to all non-menus. So in this case, we have a successful analysis and results for head nod, but we know from literature that brow movements are more complicated. And with this regard, I want to end this with the discussions and open the floor to discussions, kind of thinking more what would be the best or idealistic ways to capture non-menus and their differences. Could it be possible to combine both behavioral and computational methods? And my future dream or idea, would it be possible to have a Toby or Pratt for non-menus one day, where we can get all these trajectories or features that we do for the speech or prosody, and then we can tie this with our analysis. Thank you all for your attention and time, and I'm looking forward to your discussions and comments and questions.